Hello, good people. Welcome to our third video here of finding volumes of solids of revolution. And again, I want to reiterate, we don't need to visualize what that solid looks like. We don't need to draw it. You're never going to be asked to sketch it. You will need to know some characteristics of it that can help you set up the integral. But other than that, we have what we need with the information that's given in order to figure out the volume. So let's look at this example from 2005. Let f and g be the functions given by f of x is 1/4 plus sine of the quantity pi x, and g of x is equal to 4 to the power of negative x. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graphs of f and g. And let S be the shaded region in the first quadrant enclosed by the graphs of f and g in the as shown in the figure above. So two different regions. Part C of this problem said, find the volume of the solid generated when S, that's this region, is revolved about the horizontal line y equals -1. Well, I don't even see y equals -1, right? So y equals -1 is somewhere down here. And I don't even know where it is. So I'm just going to draw it down here. Y equals -1. So this is my axis of revolution. This is the shaded region that I'm going to revolve around about that axis, y equals -1. And so my first question is this going to be a setup that involves x's or y's? Well, since my axis of revolution is horizontal, then it's going to be a setup that's in terms of x. When I draw my rectangle, here's my representative rectangle, right? So this is my slice. But my slice is perpendicular to the x, I guess, axis, but that's shifted down. And so we know that it's going to be in terms of x, number one. Second question is the shaded region right up against the axis? Or is there space? There is space. And so therefore, we're going to need two setups, right? We're going to need a big R and a little r. So big R is going to be, remember what I said, start at your axis of revolution and draw the length that goes all the way to the outer edge of the shaded region. That's capital R. So capital R is top function minus bottom function. Top function is f of x minus bottom function is -1. Be careful. Top minus bottom, my bottom function is a -1, so minus a negative, that's going to turn into a positive, right? So just be careful there. 1/4 plus the sine of pi x plus 1. And if you want, you can put these two together and get 5/4. Second radius, start from the axis of revolution and go all the way until you get to the closer boundary of that shaded region. That's little r. But how do I measure vertical lengths? Top minus bottom. So top is this function, which is g of x, minus the bottom, which is -1. So I have to do this. And therefore little r is 4 to the negative x plus 1. So I have big R and I have little r. Awesome. Now I can write my area function. My area function is pi times, now remember, I'm doing two circles, but they both have pi, so I'm just going to factor it out. Pi of, let's go ahead and add these two and say 5/4 plus sine of pi x squared minus the little r squared. 4 to the negative x plus 1 quantity squared. If I distribute this pi, I'll have pi big R squared minus pi little r squared. That's how I find the area of one of those slices. By the way, when I do one of those slices, because there's unshaded region, because there's space in between, then it's going to be a washer. So I have to have two r's. And now to find the volume, that would be the integral from this intersection point to this intersection point, Well, gosh darn, I don't know either of those. But I do know the integrand is going to be this stuff. So 5/4 plus the sine of pi x, all of that squared, quantity squared, minus, and then 4 to the negative x plus 1 quantity squared dx. So what do we need to do? We need to find these intersection points. That's what we need. Or we need to find these limits of integration which correspond to these intersection points. So let's get our grapher. And I've preset f of x and g of x. Let's see, the window, does it tell us a window for this? I don't think so. So I'm just going to press graph and see what we see. Here is 4 to the negative x. Can I not see the other one? Oh, I turned it off. So no, I can't see it. Now let's graph it. Ah, there it is. So here's region R and here's region S. I'm looking for these two intersection points. So I'm just going to go ahead and press second trace. We're going to do an intersection, option number 5. I'm going to get closer to the first one because I'm looking for that one first. Press enter, press enter, press enter. And we get an intersection point of 0.718. I come over here and I press X and I save or store this in alpha A. 0.1782. So this is 0.1782. And then I find the other intersection point. So I go back to the graph. I press second trace. Let's find the second intersection point. So let's get closer and closer and closer to the other intersection point right here. You don't have to get right on it as long as you're close to it. Press enter. Second curve, enter. Take a guess. Just press enter. Oh, and it's 1. Well, that's easy. 1. This integral will find the volume of that solid of revolution, the one that's revolved around the horizontal line, y equals -1. And now we get to set it up. Let's see. Let's move this way, and let's set up the calculator here. So I come over here, and I say, all right, here we go. Pi. Pi is right here. That's not pi. Pi. And then let's do an integral, math 9. From alpha A to 1 of, now remember we have a bunch of parentheses, so I got to open another parentheses, and then I can do 5/4 plus sine of pi x, close it, and we need to square that, minus, and let's open another parentheses, 4 to the power of -x, plus 1, close it, and let's square that. This should be what we have in our integrand here. And I believe it is. Move out. We're doing this with respect to x. Press enter. And there is our answer, 4.559. So this is about 4.559. That's how we find the volume of a solid revolution. Just remember, solids of revolution are either going to be disks, which are circles. Pi r squared is going to be the cross-sectional area formula. Or if there's space in between the shaded region and the axis of symmetry, then it's going to be a washer. And washers have 2 radii, a big R and a little r. So it'll be pi big R squared minus pi little r squared. And that's it. Did we need to know what the shape looked like? No, we didn't need to draw it. And we're able to get the volume even if I can't visualize or don't have a picture of that shape. That's the beauty of volumes of solids of revolution.